For this next example, I wanted to do one like this because you'll notice this has two radicals. So what we're going to end up having to do is repeat our process. Like in the steps, it says if you still have a radical within the terms, then repeat steps 1 and 2. So I want to do one of those here. So the first thing we're going to do is make sure that one of the radicals is by itself. And so what I'm going to do is I'm going to subtract this square root over to the other side, so that I'm left with the square root of 2x plus 3 equal to 4 minus the square root of x minus 2. So I've isolated one of my radicals. So now in order to eliminate this radical, I'm going to have to square it, but I'm also going to have to square the other side. Although this is a little bit more difficult, you can do this. Go slow, do your steps slowly, completing all math as you go. So on the left side, I end up with 2x plus 3. On the right side, I'm going to square this out. Now remember, squaring it means I have 4 minus x minus 2 times 4 minus x minus 2. So we're going to go slow, and also remember rules of exponents as we're working this. So 2x plus 3 is just going to hang out over here. So I'm going to do 4 times 4. This gives me 16. 4 times the square root. So 4 times the negative square root is negative 4 square root of x minus 2. It just puts this coefficient of 4 in the front. Distribute. That also gives me minus 4 square root of x minus 2. And then down here, negative and negative is a positive. Square root times square root actually eliminate each other, just leaving me with an x minus 2. This is true because if you remember your rules of exponents, if you have a to the m times a to the n, basically two things where the bases are the same, you're multiplying, you add the exponents. So with these two, let me just consider it as a radical. Say I had two radicals, you'll notice the bases are the same. This radical can be written as a 1/2 power, and we're going to do a little bit of that in the next step. So if I write them to the 1/2 power, which means the same thing as a radical or the square root, my bases are the same, so I'm going to add the exponents, so that would be x 1/2 plus 1/2. That gives me x to the first, or just x, thus y. When the square roots are being multiplied times each other, you just end up with the x minus 2. So now I'm going to combine like terms, so I get a 2x plus 3 equal to 16, and negative 2 gives me a 14. Negative 4 in the radical. Negative 4 in the radical gives me negative 8 in the radical, plus x. So now if I were only considering this problem here and nothing else above it, this is like the previous two problems we did on the first video, and so I want to isolate the radical and square to solve it. So I'm going to subtract the 14 over and subtract the x over. So this gives me x, 3 and a negative 14, that gives me a negative 11, equal to negative 8 square root of x minus 2. Now I'm going to square the left, or the right, and also square the left in order to eliminate that radical. So on the left hand side, I end up with x minus 1 times x minus 1. That would be if I'm squaring it. I'm going to work that out here in a minute. If I square the negative 8, it gives me a positive 64. If I square the radical, it just leaves me with the radical left. Now I'm going to keep on going. Distribute. So I get x squared minus negative 11x, so negative 22x plus 121 equal to distribute. Now I'm just solving a quadratic from section 4. It is more intensive, does take more time. Go slow, show your work, do small steps at a time. So I'm going to move everything over, so I'm going to subtract the 64x, and I'm going to add the 128. Don't let it scare you that you have larger numbers now that you're working with. I have x squared minus 86x plus 249. Now if it really scares you, you can do quadratic formula, but this does factor, and this factors into x minus 3 and x minus 83, so then we can solve that out. Now, Of all the problems that we've worked this semester thus far, yes, this is probably the most intense problem. But I just want you to see that this here was just solving a quadratic from section 4. This was just moving things around, foiling. So really this first step and this step in here are probably the two hardest steps. But if you show your work and go slow, you'll be able to solve this out. Now I'm aware that I'm not looking at your notebook paper on your practice problems that you're completing in Canvas. I'd highly advise you get you a spiral, use that for your homework, go slow, show your steps. Because if I were to give you a problem like this on the test, obviously you can see I can't give very many of these because they're time consuming. But if I give you one, I would want to see all the steps as you go to receive full credit for that problem. Now, last step. Here's my two answers. Make sure you go back in and check it into the original. You guys know how to plug and check. Use your calculator, check it, and you'll actually figure out that 83 does not work. So 3 is the only answer that you need. So I hope this has helped with solving for these radicals. Definitely try them on your own. Practice your problems. Go into the textbook if you like. There's some more practice problems if they are not graded. Contact me if you have any more questions with those. Now for the next part, we're going to be looking at rational exponents. So kind of building upon that little side note that I also made from some previous math knowledge that you have. A rational exponent indicates a power in the numerator and a root in the denominator. There are multiple ways of writing your expression, a variable or a number with a rational exponent. So it is kind of small here, but let me write it larger. So this first one says if I have a to the m over n, then it could be written as this one here, a to the 1 over n to the m power, or it could be written as a to the m raised to the 1 over n. Just power to power, if you remember from your basic exponent rules, power to power, you multiply. So it doesn't matter if I have them multiplied together or not multiplied, I just switched them. Or like you saw in the last example, the nth root can be the bottom of that denominator. And I can also switch them up and pull one outside, etc. So it's just showing you the different ways you can write it. But with variables and numerics, let's just kind of look at it and see how it's going to work for our life here in class. Example 1 says solve the equation in which variable is raised to a rational exponent. And it says x is to the 5/4 power equal to 32. So our goal is to solve for x. I by no means want to try 1 and 2 and 3 and 2.5 and play with all these numbers. I want a very algebraic approach to doing this. So I'm going to work this two ways for you. You can either address that this is being raised to the 5th power first, or you can address that it's being 4th rooted first. So let me show you one way to solve this. So my goal is to eliminate this 5/4 power. So if I have this 4 in the denominator, that's like a 4th root. So instead of a 4th root, I would need to raise this to the 4th power to eliminate it. So I'm also going to raise this one to the 4th power. Now this does amp up my problem sign. Those forced with cancel would be x to the 5th is equal to 32 to the 4th power is quite a lengthy number. No big deal. I just typed it in my calculator. Now I can deal with this 5th power. To get rid of that 5th power, I would have to 5th root that, but I also have to 5th root the other side. Again, that comes into play what I was showing you before earlier in this section on how to work with your calculator. These two would cancel, leaving me with x equal to the 5th root of this problem, surprisingly, is just 16. So although your numbers may get large, or you might say, oh my goodness, I can't believe it has a fraction as an exponent, just deal with the small pieces, work slowly. You can do this. I want to show you an alternative way, still correct as well. What if you had 5th rooted first and then 4th powered? Would it still work out? And I'm going to say yes, it still would work out. You're not sure what to do with this 4 on bottom, but you know the 5 on top. You would need a 5th root to cancel. So I'm going to 5th root both sides. I'm going to get x to the 1/4 equal to the 5th root of 32, which will give me 2, kind of a nicer number to deal with. Then this 1/4, that is the same thing as the 4th root. So to get rid of that, I'm going to raise it to the 4th power. Again, a little bit nicer numbers to work with. These cancel each other and I get x equal to 2 to the 4th, and plug that in, you just get 16. So you can see either way that I approach this, I'm going to get the same answer. To bump it up a notch, what if I had an x plus 5 in here? Well, same process. This 2 on bottom is just like having a 1/2 or a square root. So to get rid of that, I'm going to square both sides. So it gives me x plus 5 to the 3rd power equal to x squared, which is 64. Then to get to that 3rd power, I'm going to cube root both sides. This is where your calculator comes in handy. This part cancels, and I'm left with x plus 5 equal to the cube root of 64. Typing your calculator will give you a positive 4. And then I just have one final step of subtracting 5. So definitely compared to page 3 right before this, this definitely is a little bit quicker process, but it can be confusing. I know fractions cause students to get stressed, but you can do this. Just do the small steps one at a time. This leads us into our last part, type 3, dealing with other types of equations. Just a general note, a polynomial equation is a polynomial of degree n, is an expression of the type a sub n x to the n, and it goes all the way down to a sub 0, where n is a positive integer, and they are all real numbers. Setting a polynomial equals 0 gives us a polynomial equation, and the total number of solutions to a polynomial equation is equal to the highest exponent. So in all of our quadratics, we were getting 2 answers, but now in this next problem you see I have a 3. I get the possibility of 3 answers. Now, it does talk about things being real and complex as solutions. Now, real numbers is anything that would be on your number line. Fractions, decimals, negatives, positives, zeros, pi, e, like any of those issues. Complex numbers, well, the complex number system is something that they kind of developed back in the day to help us deal with sticky situation. That sticky situation is if I have the square root of a negative number. And if you've ever noticed, when you square root a negative number in your calculator, it really gives you quite an odd answer. So what they did is they said, hey, when dealing with a negative number, let's still do our square roots like we're used to doing, like square root of 16. Let's call it 4. You know, square root of 4. Let's call it 2. But dealing with the negative, let's go the same route and say square root of 16 is 4. But to tell someone or show that I also had a negative under there, they called it I. And so now the square root of negative 16 would be 4i. Or likewise, if I had the square root of negative 4, it would be 2. And then to show you that there was a negative under that root, an I. So I just want to kind of reference and show you some of the complex, just very basic. We'll work with more with complex numbers later on. And let's go ahead and work this problem. So what we're going to do is we're going to be putting together skills that we had from solving our quadratics and also work with some of this complex that I just showed you here. So the first thing you want to do is make sure it's in standard form, it's in descending order, and it's set equal to 0. So you'll notice I'm going to group the front 2, and I'm going to group the back 2. And I'm going to do it similar to when we were solving quadratics where the lead term wasn't 1. Notice in the first 2, they have a x squared in common. 5 and 2 don't divide by anything. X cubed and x squared, they can both give up an x squared, leaving me with a 5x plus 2. Next, I'm going to look at the next 2, and I notice that 80 and 32 are both divisible by 16. So I just went my calculator, did 80 divided by 2, 32 divided by 4. Let me try 4. 4 worked. Let me try 8. 8 worked. And I got up to 16 being the greatest common factor between 80 and 32. When I pull a 16 out of both of those, that leaves me with a 5x plus 2. Putting all that together, I can bring the 5x plus 2 out front, leaving me with x squared plus 16. So just like a quadratic, I have something times something to give me 0. So I say, what if 5x plus 2 is 0? Solve it out accordingly. What if x squared plus 16 was 0? I get x squared equal to negative 16. And then notice to square root, there's my negative. X is equal to plus or minus, because I'm square rooting a variable. Square root of 16 would be 4. And then just like we talked about here, having this negative underneath here would give me an I. So notice, I had a cubic function, and so now I have 3 answers. Negative 2/5, positive 4i, compensating for that negative under the square root, and negative 4i. So this would be my 3 answers for the problem.